Today let's try to write inheritance hook or the Deadman's hook. First I'll explain the theory of how I want to implement it, and then let's code it together. I'll not be able to explain every bit of code in this video as it will take a lot of time. My guess is even if I give a brief overview of the code, it will at least take 45 minutes to explain it. I'll try my best to explain whatever I'm doing. I'll also be using hooks builder on test network as everyone has access to it and hence can code along with me. In future videos, I'll start using hooks toolkit. Yeah, that's about it. Let's get started. So let's say this is the main account. And suppose it has 10 million USD in it. Whatever is left in this account, the person wants to pass it on to the nominee. To do this, the person has to install the inheritance hook on this account and also configure the nominees. Yes, I want to have multiple nominees for this implementation. Let's have a primary nominee. This is the main person who is going to inherit the wealth. By the way, these are all accounts on Xahau Network. Now the criteria is if the main account is inactive for say 100k ledgers, then the primary nominee can take over the main account. So with this implementation, we will just set primary account as a regular key account for the main account. So that's how it can take over the main account. So the next question is, how do you know the main account is inactive? To solve that, let's have a state to record the last activity of the main account. If the main account makes a transaction on 10,000th ledger, then we make the ledger number as entry to this state. Now, what if the primary nominee loses access to their own account or the primary account itself becomes inactive before the set time period? So let's have two more nominees just in case. Let's call it second and third nominee. Remember, these are just accounts on Xahau Network. It also makes sense to have a separate criteria for them to take over the main account. Let the time period be something like 200k. So here the idea is the primary nominee should always have the priority. If the primary doesn't claim the ownership, then the second and third nominees come into play, or else not. Or after some time, the primary nominee becomes inactive, say for 200k ledgers, then the third generation can take over, or something like that. I think this is all we need. We can implement this in a lot of ways, but this is what I'm going to implement today. So let's call this main account as hook account because hook is installed on this account. And the last status, we store current ledger number whenever the hook account makes successful transaction. Let's call this primary as P, second as S, and third as T. And these criterias as L1 and L2. That's it. I think that's all we need. Let's go to hooks builder, select the starter template. And let's get started with declaring an unsigned array of 20 bytes. Here I'm using a hook API called OTXN field to fetch a field, that is account field, from the payload. So whoever is invoking this hook, their account ID is fetched here. Similarly, I'll also fetch the hook account ID itself using hook_account API. That is the account on which this hook is installed. Now the next step is to see if these variables have same account ID. That is, the owner of this account is in fact invoking the hook or is making the transaction. So we have a macro for it called buffer_equal_20, which checks the first 20 bytes of both the past parameters. So if it's not equal, then it's most likely an incoming transaction and definitely not an outgoing transaction. And if it's equal, then it's an outgoing transaction initiated by the hook account. So we record the current ledger into the hook state, indicating the account was active at this ledger index. So current ledger is not a buffer, it's a variable. That's why we store it with svar. So this is how you store something in a state. Set state svar, since current ledger is a variable and not buffer. If it was buffer, you need to use sbuff. And let's give it a key. Let's call it last. So last, the key is 4 bytes. Let's see if it actually copied 4 byte into the state. If not, let's error out. Let's roll back the entire transaction. So if it's not equal to 4 bytes, because current ledger that has 4 bytes of data, we roll back. Let's also declare some macros for it, because we'll be using rollback in a lot of places. Rollback sbuff of the message and underscore underscore line underscore underscore. This is a built-in macro. Do not end macros with a semicolon. Let's do the same for accept. And now let's use these. Transaction successful. And instead of rollback, let's put nope here. Also, it's a good practice to also include the name of the hook. If you have multiple hooks installed, you know which hook actually error out. Could not set recent activity state entry, so bailing. So that's it. That's it for tracking the active state of hook account. This hook must be set to be triggered on all transactions. So we should install the hook on this account, and this hook state has to be updated each time the hook account makes any transaction. Now let's move on to the next part. Let's make it a second hook and let's hook it on to invoke transaction. The hook builder doesn't support installing multiple hooks at the same time, so let's take the important part out of this hook and put it in our next hook for demo purpose to make it all work by the end of this video. Since let me just copy this entire code here. Open the hook builder once again, select starter template, paste it here. This is the second hook. Since we have multiple nominees, let's have a flag to identify different cases. Let's use OTXN param to read the parameters sent by the user while invoking this hook. We are just expecting 1 byte of data from the user. So F 1 byte. If it's not 1 byte, then it's a wrong data and we roll back the transaction. We can say inheritance, no action specified, or something like that. So in this hook also we need to know who triggered the transaction and the hook account. So we will leave this code here. Let's write different blocks for different nominees. If the user passes 00, then it's hook account for configuring the nominees. You can say it as 00 here or the hex format. I prefer hex format. 01 for primary nominee, 02 for second nominee, and of course 03 for third nominee. Actually, we don't need parameters for nominees since the nominee account will be present in the state already. We can check if a nominee invoked it and do the needful. But let's do this way for now. For clarity, I'll go ahead and create a new account for this block, that is the hook account configuration block. I'll go ahead and create a new account and call it, let me call it inheritance itself. We are not going to install it right now. Let's just see how the transaction is made. This hook can only be invoked on invoke transaction. So select it, select the inheritance account, and these are the configurations we need. The parameter, the flag, which is 00. And then we need to pass in the primary nominee information, second and third nominees. Remember, these are hook accounts, so it's 20 bytes. L1 is 4 bytes, L2 is 4 bytes. These are the criteria. Hope you remember from this diagram, P, S, T, L1 and L2. These configurations must be passed on by the hook account itself. That's the configuration part of it. Okay, let's code this part now. The first thing to check here is this block should only be executed by the hook account, the actual owner of this account. We already have code here. Let's copy it. So if the invoking account is the same account as the hook account, then proceed, or else roll back. I think it's good to go with the rollback logic, so I'll say if it's not equal. We actually need this current ledger at multiple places, so let's put it outside the local scope of this flag. This block of code, we don't need it in production as it's handled in the first hook. For demo purpose, I'll leave it here. So now if the hook account didn't invoke it, then it's an unauthorized call. Somebody else passed this flag. So we can say, we can just roll it back with some message to the user. You are not authorized to do this. If it's from the hook account, then check if the hook parameter has primary nominee detail. So take a parameter, take a variable, a buffer, call it P. So once it's fetched, store it in hook state. Since it's a buffer, use sbuff and P as the key. If the data copied is not 20 bytes, then fail, because account ID is always 20 bytes. This is sbuff. So let's do the same for second and third nominees. So replace it with proper names. And same for third nominee. There are many things we can do here. For example, let's make sure the nominees are not repeated, because it defeats the purpose if it's repeated, right? So we can again use buffer equal 20 macro here, which we have it here. Copy paste it. So let's check for primary and second, and then third and second. Copy this. If primary nominee and second nominee are, let's make it, if they are equal, then just say we can't repeat the nominees. Similarly for third, if it's equal with second, Or I think we also have to check if the third is equal to the primary. Just roll back with this message again. What else is left in the configuration? Yeah, L1 and L2. Let me grab this code. Let's call it primary interval. This is 4 bytes variable, so use svar while storing it. Let's not make it a buffer. It's in 32, unsigned in 32, which is 4 bytes. Make it svar L1 and 4 bytes. If second interval, okay, copy paste it for L2. Let me call it second interval, something like that. Also, let's check if secondary interval is less than or equal to primary interval, then roll back. So non-primary, okay, wait. Secondary ledger interval must be greater than primary ledger interval. Oh, we forgot to save it to the hook state. Let's do it now. It has to be sbuff actually, not s. It has to be svar, not sbuff. And I'm telling this again, this code is not needed in production as we have a separate hook to track the account activity. So this is the end of configuration. So accept the transaction as successful. So it's done. The control need not flow any further. Now let's see if it actually executes without any error. Okay, that executes successfully. Let's move on to the next part, the primary nominee taking over the hook account. This one. And the criteria is some ledger intervals after the last activity, after the last active state of the hook account. So let's first get the last active state of the hook account. It's easy for addition and subtraction if it's a variable and not buffer. So if this block of code gets executed successfully, then the hook must set the primary nominee as the regular key to the hook account. Let's go to xrpl.org and search for set regular key. I think this is what we need. Okay, this is exactly what we need to set the regular key. Copy it. Go to this tool from Dennis. Shout out to Dennis for this tool. Don't worry about these values. The tool doesn't consider it. Now hit convert. Fantastic. Copy this code, go back to your hooks builder and paste it at the top. maybe here, yeah. You can see some values at the beginning and zeros following it. If you want to know more, you can go back to xrpl.org and search for binary format, I guess. Yeah, I think it's binary format, and try to read and understand as much as possible from this page. I think there's something else. Let's scroll up. I'm looking for type code and field code. Yeah, this one, especially this part. Okay, so let's get back. We don't need the flags, so I'll remove it. So we have template for the first three parts, these offsets, by the way. Account out has to be hook account because the outgoing transaction should be from the hook account. So let's copy, instead of this, use the macro. And since it's a macro, sbuff can't do size of this macro, so we need to specify the length manually. So I'll put this account out, comma 20 bytes. Let's see where we have used account, hook account. This is one. And that's fine. I think that's all. Now let's look at our key out, the regular key. So we should also check if this block is being executed by the primary nominee. So let's fetch the primary nominee from the state and compare it with the account which invoked this hook. So we already know this code, but let's replace the buffer primary with the macro r key out. Since it's a macro, let's explicitly state its number of bytes, which is 20 for any account ID. Now check if this block is actually executed by the primary nominee or not. R key out and trigger account. So buffer equal 20 always checks the first 20 bytes. So you need not specify the number of bytes for the macros. This does the job. If it's equal, then we already have the nominee details in R key out. We should perform the same checks for all the nominees. So let me copy it over. Yeah, this section. I think we need everything here. Yeah. For the second nominee, change the variables. This remains the same. Let's do the same for the third nominee. Change the key, it is T. Since this code is repeated everywhere, let's remove it and put it outside the flag scope so that all the scopes have access to it. And oh, we forgot the main thing. We have to check if the set ledger interval has passed. Let's fetch primary and secondary interval from the hook state. Let's start with this primary nominee. Let's take a variable of 4 bytes. Unsigned int 32 svar, and it's L1. And it's 4 bytes. Now the important check. Let's check if last ledger plus ledger interval is less than the current ledger. We'll calculate it as ledger elapsed last plus ledger interval. This gives the ledgers elapsed. And we need to check if the current ledger is less than this. We have a nice template for this. So we have current ledger here. We have a nice template for this. Let me copy it over. And we have message buff here. Let me copy it over here at the top. So this is the message you get. You must wait whatever ledger it is, that many ledgers. So we can roll back with the message buff. Please take a moment to analyze this part. It's simple but still can get confusing. Now so I think it has to be less than current ledger has. If it's less than the ledger elapsed, then roll back. Now let's fetch secondary interval for second and third nominees. Again, the code is same. Let's copy it. Here we are checking for the condition. Let me copy this. Second interval. This part of the code is same for the third nominee. Let's just copy it. So if you see here, the second interval part is repeating. So let me remove this. And also put this code outside the local scope of this flag. That way both flag 2 and 3 can access it. So now, based on which nominee successfully invoked the hook, the regular key is copied and we need to emit the transaction to actually set the nominee as regular key account for the hook account. As I said, the emit out, we can copy the code. Here we are indicating that this hook will only make one emission to the max per invoke. Don't worry about these lines as of now. Emit out, you have 116 that comes from here, 116, and it states the offset here, which is 113, and this part of the code here calculates the fees. This has to come at the end just before actually emitting the transaction. All the values get filled based on the offsets here, and then we calculate the fee at the end, and then the hook emits the transaction. Now let's accept the transaction as successful. Now let's accept the transaction as successful with a proper message. Maybe regular key set successfully. Let me save this. Let me compile. But this code is repeated. Let me make it a macro. Remember, making it a macro doesn't optimize the code. It just looks cleaner. So this has to come after message buffer declaration, as we are using message buff in this macro. Let me call it set message. Let's pass 2 parameters to it, which is current ledger and ledger elapsed. This is multi-line macro, so we need to have this backslash everywhere. And the important thing here, the parameters, wherever it appears, it has to be inside small brackets. I'll make another video to demonstrate why it's very important. So let me quickly select them. Okay. Now this all looks good. Let's go ahead and replace the code with the macro. We can safely remove this now. Similarly, let's copy message set now and replace this. Okay, looks better, cleaner at least. Let's execute it. That's it. Make sure you save this code by pressing Command S or Control S to save the code, and then compile it. Let's install the hook. Make sure to select the invoke. Click on set hook. This installs the hook. Next, let's configure the hook. Remember, it has to be configured by the hook account. So select inheritance hook. FF is 00. This is the configuration part, if you remember. Please remember these blocks and who is authorized to run it. Let's create a primary nominee. I'll call it primary. Okay, this is the R address, but we need 20 byte account ID format. Let's use this tool. Get the account ID. Go to test tab and paste it here. Click on update fees here. Let's execute and see what error we get. Let's see. Oops. Specify the primary nominee. That was not what I was expecting. It should complain about secondary nominee, right? Because we are already passing the primary nominee information. Let's get back to code. The bytes are wrong. Account ID is 20 bytes. I think I copy pasted it everywhere now. This is 20 bytes. This has to be 20 bytes. And third account, this is 20 bytes. Where else? This is 4 bytes. Because we are copying 4 bytes, right? This got to be 4 bytes too. Okay, don't forget to save and compile again. And make sure to set hook again each time you make an update. Let's check now. Okay, specify second nominee. Now it works. Let's create second nominee. Do the same thing, copy the R address, go to this tool, paste the R address, get the account ID, pass it as second nominee. Now the third nominee. We can't create another account before 10 seconds are passed. So let's check other configurations. L1, let's give it as 100, which is 64 followed by 6 zeros. This is how you write 100. I'll show you how to calculate it in README file of GitHub repo. I'll put the link in description section of this YouTube video. I'll copy the same value to L2, which should throw error, as L2 should be greater than L1 in our case. Now let's get back and create third nominee. Hope 100 seconds has passed. Okay. This is the third nominee. Make sure to update the fees. This should error here. The secondary ledger interval must be greater than the primary. Yeah, as expected. Let me increase it a bit. This should successfully configure the hook. And it does. We can check this on the Explorer. Click on the inheritance account. So this is the object where you have hook hash information probably. Yeah. And go to the latest transaction. You can see the past parameter. By the way, these values are also in hook state. You can copy this R address or your R address and go to XRPL win, switch to a Xahau test network and check it. Okay, now the interesting part, the claim for nominees. It's still an invoke transaction, select the primary nominee. Now destination is important here, and it's the inheritance account or the hook account. If you just execute like this, it will fail. So pass the correct flag. What if you pass wrong flag? 00, is for the hook account, not for the nominees. But let's execute it that way. You're not authorized to do this. That's nice. So let's pass in the correct flag. Regular key set. That's all good, but I expected that we need to wait a couple of ledgers more to do this. Let's get back to the code. Shit. I don't know why I wrote L1 here. It has to be last. That's the state key where we stored the last active ledger index. Yep. Save, compile, set hook again. I'll go fast and configure one more time. Debugging actually becomes easy if you do all these locally via scripts and also just using Hooks toolkit rather than Hooks builder. But if you are a beginner, don't get stuck with Hooks toolkit and debugging stuff. Before getting started, just use Hooks builder. Once you execute one or two hooks, I would highly recommend to go with Hooks toolkit. That's easy for debugging. I choose Hooks builder today because not everybody might have Hooks toolkit installed. All fine now. Now let's claim as primary nominee. Look at this beautiful message here. You must wait until these many ledgers. Very intuitive for the user, right? So let's click after some time. There's one more interesting thing with this message. Let's click on the primary nominee account here because it's not passing, right? The hook is not allowing the transaction to be successful. And what message is the user getting? Click on the hash, hook executions, and copy this hook return string. Go to hex to ASCII. You can do this using Node. So here the user sees this message. You must wait these many ledgers. That's what user sees when the transaction fails. Very neat. So let me wait. Okay, we are very close. I hope it sets the regular key properly. Okay, one last time. Done. Yeah. Regular key set successfully. It emitted the transaction successfully. Let's check the nominee. Let's check the inheritance hook and see if the regular key has been set. And as you can see here, there is a regular key set. RHGM, which is the primary key, RHGM. Yeah, this is the primary account which got set as the regular key for the inheritance hook, thereby getting full access to the inheritance hook. We can do a lot more with this hook. For example, check if the flag passed is greater than 3 or less than 0, in which case it makes no sense, right? So just say wrong action specified or something like that. There are many more things we can do with this hook, but I'll put this on GitHub. You can all fork it, use it, modify it, and you can find the link in the description section of this YouTube video. Hope you like it. Thank you for watching till the end, and see you in the next one.